I need to classify what is the type of the soil Z, what is the type of the soil Y, and what is the type of the soil X by reading or analyzing what is the analyzing the data in the grain size distribution table. So in classifying using AASHTO, I use these two table by to identify what is the type of the soil. So in classifying using USCS, I use this table to know what are the type of the soil. So in soil X, I analyze that, or I acquire the data from the grain size distribution table that it has in sieve size number 4, its percent passing is 49 and its percent retained is 51. So in sieve size number 10, it has a 32% passing and 62% retained, and in sieve size number 40, it has 12% passing, 88% retained, and sieve size number 200, it has a percent passing of 2 and 98% retained. So now, first in classifying using USCS, I identify that soil X has a D10 of 0.27, D30 of 1.5, and D60 of 6.35. So now, to analyze, to classify the soil type of X, now we have, first we have a sieve size number 200 of 98% retained, so meaning it is a coarse. It is a coarse, and according to the table, then number 200 sieve size has 2% passing, so the number 4 sieve size has 49% retained, so meaning it is sand according to the table. So CU is equal to, I identify the value of CU and CC, that it has a CU is equal to 23.52 and CC is equal to 0.87. So using this data, I classify this soil as a poorly graded sand. So next is by the use of AASHTO. So in identifying using or classifying using AASHTO, I assume that the soil X has a liquid limit of 40, plastic limit of 24, and PI is equal to liquid limit minus plastic limit, so it is equal to 16. Using this assumption and the data in the table of grain size distribution table, I classify that soil X is A-2-6. Then A-2-6 is using when you classify a soil using classify as a soil as A-2-6, you need to use the formula of group index as 0.01 times F200. F200 is the percent passing on sieve size number 200, and then minus 15 times PI minus 10. So GI of soil X is equal to negative 0.78, or it is equal to, or the implication of it is equal, it has a higher quality of subgrade. So now soil Y has data of percent sieve size number 4 has 100% passing and 0% retained. Sieve size number 10 is 87% passing and 13% retained. So sieve size number 40, it has a 0% passing and 100% retained. So next is sieve size number 200, has a 0% passing and 100% retained. So by USCS, so I identify first the D10 of the soil X is as 0.71, D30 of 0.85, and D60 is 0.95. So according to the table in classifying the USCS, I using USCS, so it has when number 200 sieve size has a 100%, so it means it is a coarse. So number 4 sieve size 0% retained, so meaning it is sand. So using the percent passing on sieve size number 200 and the CU and the value of CU and CC, so CU the CU of soil Y is 1.34 and CC is 1.26, so meaning it classifies as a poorly graded sand. So next is classifying the soil type using AS2. So I assume that soil Y has a liquid limit of 41 and PL is a plastic limit is 27, and then PI is equal to 14. So using my assumption, I classify soil Y as A-2-7. So meaning A-2-7, we need to use group index formula of 0.01 times F200 minus 15 times PI minus 10. So meaning this GI of soil Y is equal to negative 0.6, or it means that it is a higher quality of subgrade. So now soil Z, according to the by analyzing the table of grain size distribution table, I acquired the formula, or I obtained the data of soil Z as at sieve size number 4, it has a 100% passing, 0% retained. Sieve size number 10, 100% passing, 0% retained. And sieve size number 40 has 90% passing and 0% retained, 10% retained. And sieve size number 200 has 63% passing and 37% retained. So assuming that it because soil Z has greater than 60 according to this table. So when soil is less than 50% retained sieve at sieve size number 200, so we need we need to find its liquid limit, or the plasticity index. So I assume that soil Z has a liquid limit of 52, PL plastic limit of 41, then PI is equal to 11. So it means that the liquid limit of soil Z is greater than 50, so meaning it is below A line. So analyzing that using this table, I identified that the classification of soil Z using USCS, it is below, because it is below A line, so it is MH elastic silt. So now by the classifying using AH2, I assume that the liquid limit is 52, the PL is 41, and then plasticity index is 11. So in classifying the soil type of soil Z for A dash, because it is classified as it will belong to this what do you call this? So this, because it has more than 35% of total sample passing number 200, so we need then the by because it has it is classified in the, it's either A-7, A-7-5, A-7-6. So we need to choose whether it belongs to A A-7-5 or A-7-6, we need to use this formula. So computing the formula or substituting the given data to the formula for A dash, it will classify as A-7-5 because its plasticity index is 11 less than or equal to 22. So meaning the classification of soil Z is A-7-5. So because it is classified as A-7-5, we need to use the formula of GI as F200 minus 35 times the quantity of plus quantity of 0.2 plus 0.005 times 11 liquid limit minus 40 plus 0.01 times F200 minus 15 times PI minus 10. So GI of soil Z is equal to 7.76, or because it has a 7.76, so meaning it is a lower value of subgrade, or so that's all.